Is it audible?
Yes, sir.
Okay, fine. Just a minute. Is it audible, right? So in the last class, what we have finished is just agaricomycotina and a couple of mushrooms and all those things we have discussed, right? So today's class is about Puccineomycotina and Eustilaginomycotina. Yeah, Puccineomycotina and Eustilaginomycotina, which means rusts and all the smut fungi are comes under this Puccineomycotina. Rust means Puccineomycotina, smut means Eustilaginomycotina. So we'll see just like important features, especially in the rust fungi, what all the different rust genera are there, like the kind of teleospores and all those things, life cycle, all the stuff in this rust. Coming to the smut, of course, bunds also comes under this, right? So what are the important smut and their causal organisms? If there is any specific points that will, all those things that we will take into this. Yeah, this is the classification we might have saw already, like Agaricomycotina, Agaricomycotina, which means all the mushrooms we have discussed combined, right? So today's class is about Puccineomycotina. Yeah, Puccineomycotina. So mostly the rust fungi comes under this. Like you can take the Puccineals like Puccinia, Euromyces, Cronartium, Melomsora, Phragmidium, Pacospora, Hemilia. These all are the rust genera, rust causing genera. Now, what is the specific symptom of or the specific identification feature of this rust causing fungi? How can you identify it is a rust, or how can you identify?
Development of pustules. Development of pustules.
Okay, development of pustules or anything else? So generally, what will be the color of this rust pustules are the like the yeah generally it's a brown color, maybe orange color, or sometimes a red color. For example, you can take wheat stem rust. Generally red color rust pustules, orange rust is there, like brown color. So generally the pustules are this. The color of these pustules are associated with generally the color is like red color, maybe orange color, or maybe dark brown color. Such kind of things generally observed. So rust is generally characterized by the presence of rust pustules can be present on the infected plant parts. You can take leaf, or maybe sometimes you do also observe on the stem, right? So this genera rust, the order it comes under Puccineals. Previously, this Puccineals order is called as Uridineals. Now it is called as Puccineals. The important genera comes under this entire this Puccineomycotina, or sorry, this uh, rust causing genera. Just 1 minute. Yeah. So the rust causing genera, this Puccineomycotina, the important genera comes under are like Puccinia, Hemilia, Euromyces, Melomsora, Pacospora, Phragmidium, Gymnospora, extra. These are all repeatedly studying genera. Like if you go, everywhere, majority of the cases we do encounter with this Puccinia, because majority of the plant disease, for example, I would say 75% of the rust diseases, among that 75%, 95% of the cases are diseases that is associated with this Puccinia. Around 8,000 species of Puccinia graminestritis have been reported so far. 8,000 plus species are actually classified under this rust. That especially this Puccinia. See how large genera it is. So as I mentioned, this Puccinia is one of the largest rust genus that was followed by another genus that is called Euromyces. So generally, clamp connection is rare or maybe absent in the rust genera. So clamp connection is very rare, or maybe sometimes is also absent in the rust genera. And another thing, dolichopore septum we might have discussed. This rust and smut genera possess no dolichopore septum, right? Dichorization takes place through this somatogamy and spermatization we have observed. We have already discussed, right? So the kind of sexual reproduction mainly observed in this rust fungi, especially wheat stem rust fungi, is spermatization, where they produce male cells or male sex cells called spermatia. So produced from another flask chapter called spermagonia. So it will come in contact with opposite sex, that is called receptive hyphae, and again there will be fertilization takes place. This is how actually the rust reproduction will happen. Mostly it is in the case of wheat stem rust, it is spermatization. In the case of some other kinds of rust, or maybe in general, it is somatogamy or spermatization. And the most another important feature is the rust having polymorphic life cycle, or we can also call as pleomorphic life cycle. What do you mean by pleomorphic or polymorphic? Can anyone will tell what is this pleomorphic or polymorphic?
More than two hosts.
More than, no. What is the term, or
No,
the what is the
no,
meaning?
sir. The production of different morphologically. Morphologically different types of
Yeah,
type
fine.
is different.
No, not sure.
Type of spores are produced in life cycle.
You know what is metamorphosis? You know,
Conversion of egg into adult, that is called metamorphosis. That is mainly in case of insects.
in general, metamorphosis means you can take any organism or maybe eggs or something else. So it will start with a small organism. It will keep on increasing, adult, middle age, young age, middle age, and old age. So the same thing is changing into different forms. So that is generally called as polymorphic, changing their forms or changing their according to the situation, changes their condition. For example, you can take everything is came from a single spore only. You can take iridospore become teleospore. From the teleospore, basidospore is coming. Basidium is going and falling again. From the basidospore, pycnia is coming. From the pycnia on the reverse direction, Asia is coming. Again, this Asia come and infect on the wheat. Again, this Asia-spore from the iridospore coming. Again, the same spore keep on changing. That is a polymorphic, having more than one morphological forms. That is generally considered as a polymorphic. Poly means many. So yeah, wide variations. Generally, it is like the same thing showing a different, what can I say, like different forms. The same spore is converting into different. For a iridospore is the same again converting into teleospore. From the teleospore, basidium is coming. Like the same spore. It is keep on changing based on the condition, host or environmental condition. So more than one kind of form are having or maintaining the more than one kind of form. It is generally considered as polymorphic. The wheat stem rest is the best example for that, right? So it produces five different kinds of spores. Five different kinds of spores is not completing the life cycle in the same host. Again, two different hosts. One host is in somewhere else and another host is in somewhere else. For example, you can take wheat is growing on South India. So South India only in Nilgiri Hills. You can take mostly Punjab. So whether like in South India, you can take Madhya Pradesh and parts of like you can take some parts of this like Punjab. So wheat is growing, but if you see barberry was not there in India. Then how this is actually completing the life cycle? Like again there is a variation. Like if the host is not available, again this iridospore keep on infecting. That's why iridospore is also known as a repeating spore because it keep on infecting when the host is available, and again it will go and infect this went and infect this barberry. Again the life cycle, this Asium, Pycnium and Asial stage completes on the barberry. Again this Asiospore come back to infect this wheat. Now again Uridium and teleal cells that happens on the wheat. It's like very complex life cycle. The same spore is converting, diverting, all the things is happening. So this wheat stem rest is a best example for pleomorphic life cycle. We can also call as polymorphic life cycle. The same thing is converting or biologically converting into different forms according to the situation and requirement. So here, if you see wheat stem rust, like this question was asked, like which of the following pathogen is a pleomorphic or polymorphic pathogen? Wheat stem rust. Okay. So another thing is like production of many forms. Yeah, so same thing. Just now we have discussed. The production of many forms in the life cycle is called as polymorphism. Generally, wheat stem rust. Hope you guys know they will produce five different kinds of spores. What are all the five different kinds of spores? What are all the five different kinds of spores that is produced by wheat stem rust fungi? Are you guys are there? Pycnium, Asium, Iridium, Telium, Basidium, all these structures, the spores will come out. From Pycnium, Pycniospores will come, Asium, Asiospores will come from Iridium or Iridinia or Iridia. Iridospores will come from Telia, Teliospores, and Basidia from Basidiospores. All those, five different spores are there. So wheat stem rust is the best example of heterogeneous macrocyclic rust. Can you tell me what is heterogeneous macrocyclic? Tell me what is heterogeneous. Yeah, pathogen requires two different hosts, morphologically different hosts. Like I would say, biologically different hosts. In fact, they are not belonging to the same families. So different family. For example, you can take wheat belonging to the family of Graminae, or you can call it as uh, Poaceae, right? So, for example, you can take this one barberry. They belong to the family of Barbaraceae, which is completely biologically different, right? So, hetero means the pathogen require two different hosts to complete the life cycle. Macrocyclic, macro means generally macro means major or In soil science we might have studied in UG like micronutrients and macronutrients means they require in higher quantities, micro means they require in medium quantities or low quantities. When it comes to here, macro means all 5 spore stages are present. Micro means maybe 1 or 2 spore stages out of 5, 1 or 2 spore stages are absent, sometimes maybe 3 also absent. So generally this is the best example, or wheat stem rust, the best example of heterogeneous macrocyclic rust. All 5 spore stages are present. All 5 spore stages they complete their entire life cycle in two different unrelated biologically different hosts. That's why if you understand the life cycle of wheat stem rust, half of the pathology in our hand, because the remaining half is like other parts will be there, but the complexity of this wheat stem rust or the life cycle is completely different or entirely different. If you at least understand 30-40% also, it will be fine, right? So how exactly this spore is forming, how exactly this is actually spreading and all the stuff, like so completing this life cycle to unrelated biological host which is present in different areas. So it is not an easy task. And another important thing, when I was studying my UG very long back, when our professor said like iridospore can travel without any halt 3000 kilometers without any halt. I thought that whether this iridospores is having any highs, or like is it full of petrol, is it traveling, how it is traveling, whether it will ask, I was completely doubted at the time. Like iridospore, it is a very small spore, we can't even see with our eye. It is traveling 3000 kilometers without halt. Without halt means it is stopping nowhere. So once it is started from, just example from Palani Hills, South India, it will directly go to the Nilagiri Hills, or maybe the parts where this barberry is growing. Not again at the time I also have one more doubt, like how exactly this iridospore is finding the host, whether it have a highs and whether it will identify. Of course, even though it have a highs, how this iridospore knows this is the barber, again we need to go and fall on that. Look, at the time our maturity is like that. Now we realize it will travel through with the help of wind currents or with the help of these clouds. Again, actually not one iridospore, millions and billions of iridospore will travel, at least one will fall nearby. Again from there the soil from iridium teliospore will come, again from this tedium bestiospore will go and fall on the barberry leaves. From this barberry only again it will go and penetrate inside the germination tube and all the stuff will form. Now we realized, at the time it is a full of confusion, right? So then I later realized why our teachers used to tell that, if you understand this wheat stem rust life cycle, half of the pathology in our hand. So and I will try to deliver like in a simple way to understand the wheat stem rust life cycle. I think in the last session, like when we conducted free training last year, right? And there is a professor came, like J Ganesh is one of our professor. So he came and explained about wheat stem rust life cycle like for almost 2 hours. Like I think if I am right, almost 2 hours he explained in detail about all the wheat stem rust. I'll put in a simple way. So what are all the points that we need to take into exam consideration? And another thing is like to understand in a simple way. Okay. So first understand something. These 5 spore stages are present in the wheat stem rust: pycnium, pycniospore, achiospore, iridospore, teliospore, and basidospore. So to understand more, there are some terminologies. Let's see first. Like yeah, we'll go with this. Both are same only. So autoecious. Auto means the complete the life cycle in a single host. Generally, autoecious life cycle means entire life cycle can be completed in a single host. If the path, I mean, if the life cycle is completed in a single host, it is called as autoecious. Hetero means different. So if the pathogen require, or if the pathogen completes life cycle more than one host, or if it is require more than one host, it is called as hetero. Hetero means different, right? So which in general, like in a definition, it requires two different hosts or biologically unrelated hosts to complete the life cycle. It is called heteroecious. You remember two things. Autoecious means the pathogen complete life cycle in a single host. Heteroecious means the pathogen require two different hosts to complete the life cycle. Now another terminologies will bind. Microcyclic, actually micro means short life cycle of rust, or short stages of rust is present. Generally short life cycles or short cycles of rust is present, which means all 5 spore stages are not present, maybe 1 or 2 spore stages are absent. For example, if you see here, you will take a look at the microcyclic rust, mostly this axial and iridial stages are both are absent, especially in the case of malvacearum, that is Puccinia malvacearum. This axial and iridial stage is absent. Mostly this iridial and axial stages are absent. So this microcyclic means short-lived life cycles are present. All 5 spore stages are not present. Maybe 1 or 2 spore stages are present in the life cycle. As I told you, this hollyhock rust, this is Puccinia malvacearum and Puccinia heterospora and Puccinia chrysanthemum, where this both axial and iridial stages are absent actually. Macrocyclic means long cycle rust. The name itself indicates macro, right? Long cycle rust, but all 5 spore stages are present. Okay. Demicyclic, it is a very important. Demicyclic means lack of iridial stage. Completely iridial stage is lack. So just 1 minute. Hello. Yeah. Yes, please. Yeah. If you don't mind, can you call me after 9:30 because the class is running right now? Yeah, please. Yeah. Sorry for the interruption. Is it audible now? Yeah, fine.
Yes, sir.
Yeah. So demicyclic means lack of iridial stage. So if the iridial stage is absent, it is called as a demicyclic rust. Okay. For example, 5 spore stages, among the 5 spore stages, iridial stage is completely absent. That is called demicyclic. Sometimes 2 stages is also absent, but generally, in general, demicyclic means lack of iridial stage. Last 10 years you can take, this question was asked 5 to 6 times, lack of iridial stage, demicyclic. This question was asked in 2021, this question was asked in 2019, no, 2023, 2021 this question was asked, 2023 this question was asked. I still remember this question was asked in 2021 because aside to me, so for continuously our 10 Annamalai members were sit side to side. One of our classmate, she was asking like, hey, demicyclic means what da? So I said lack of iridial stage because in general, like before going exam, they used to ask like before starting the exam. But fortunately, that question came like just before discussion, like we were discussing, lack of iridial stage is known as demicyclic rust. So this question was asked in the last 5 years. You can take 2 to 3 times this question. What is demicyclic? Or lack of iridial stage is known as what? Demicyclic means lack of iridial stage, or lack of iridial stage is known as demicyclic. This is a very important one. That doesn't mean remaining is not important. As I told you, every single slide is important. Okay. And one more point I thought to tell you in the yesterday class, not only weekly tests, you can also take into consideration of daily tests, because daily tests are very important. We are concentrating on a very peculiar, every particular aspect, right? So those are also very important to understand the concepts very easily. Okay. So anyway, you can take this daily test also into consideration. I will tell you at the end. So anyway, coming back to this point, macrocyclic means 5 spore stages are present. These are long cycle test. Demicyclic means lack of iridial stage. Let me come once again in a fast way. Autocyclic means complete life cycle in a single host. Heterogeneous means require 2 different hosts. Microcyclic means all 5 spore stages are not present, maybe 1 or 2 spore stages are absent, short-lived cycles. Macrocyclic means long-lived cycle, but all 5 spore stages are present. Demicyclic means lack of iridial stage. Now you tell me, what is autoecious macrocyclic rust? Autoecious macrocyclic rust.
Black stem rust.
No. What I'm asking is art. No. I'm not asking example. Anyway, black stem rust is an example of heterogeneous macrocyclic rust. What I'm generally asking, you just
single host all the 5 cycle
exactly. Example I'm telling. Yeah, take a look at this carefully. Yeah, forget about this. I will come back once again. Yeah, you take a look at this. Forget about the examples. Okay. You tell me autoecious macrocyclic rust. What is autoecious? The pathogen completes life cycle in a single host. What is macrocyclic? All 5 spore stages are present, which means the pathogen complete all the life cycle, all the 5 spore stages in a same host. That is called as autoecious macrocyclic rust. Best example, BFSS, shortcut. B means bean rust, F means flaxseed rust, S means sunflower rust, S means safflower rust, C means castor rust. All the causal organisms also very important. For example, you can take what is autoecious demicyclic rust. Can anyone will tell what is autoecious demicyclic? You just tell me the definition. Forget about the examples. I will take care of it. I will tell you. You just tell me what is autoecious demicyclic. What is demicyclic? Lack of iridial stage.
Completes life cycle in single host, lack of iridial.
Exactly, that's it. Heteroecious macrocyclic means hetero means requires biologically 2 different hosts. Macrocyclic means all 5 spore stages are produced, but the life cycle finishes in 2 different biologically unrelated hosts. You can give an example of heteroecious demicyclic rust. What is heteroecious? 2 different hosts. What is demicyclic? Lack of iridial stage, which means life cycle will complete in 2 different hosts, but iridial stage is absent. Like that, examples I have given here. So anyway, don't worry about it. I will come once again. Before that, we'll come, life cycle stages. Like these are all the life cycle patterns in the rust. So, like you guys know what is autoecious, what is heteroecious. You guys know what is microcyclic, what is macrocyclic, what is demicyclic. Please remember this demicyclic means lack of iridial stage is known as demicyclic rust. Okay. Three different hosts. So I think it's supposed to be discussed in somewhere else. Anyway, I will come back once again. Yeah, let's see other points and I will go back there. Okay. So this in India, the first appearing rust in India is like brown rust and orange rust or leaf rust. That is in the last week of November in general. So if you see this, there are three different kinds of rust like we do generally study in wheat: stem rust, leaf rust, stripe rust. Among the three rust, yellow rust has no alternate host, which means no alternate host means so far not reported. Okay, so there might be alternate host, and a couple of articles it is mentioned that Mahonium, Mahobarbary, and other species supposed to be the alternate host, but it is not clear and it is not yet reported. But this yellow rust has no alternate host, have been reported so far. Okay, no acial stage is present in the coffee rust. Coffee rust is caused by Hemilia vastatrix, right? Yeah, Hemilia vastatrix. Okay, this Hemilia vastatrix was very severe in Sri Lanka, and it is introduced to India in the year when this Hemilia vastatrix or coffee rust introduced to India.
1879.
It is 18. No. It is actually 1869, close to, yes. 1869. Probably it's not 1879, it's 1869, because in 1870 the spread of this coffee rust was very severe in India also, because at the time, see, actually in before colonial rule, or at the time of colonial rule before 1940, especially in up to 1880, up to 1870, the Britishers were using this Sri Lanka as a coffee hub, which means 90% of the all the coffee production, whatever that the world is using, they are producing from this Sri Lanka only, because this is a complete coffee hub. So it's pure and pure of monocropping. Every entire, if you take all the Sri Lanka is all about the production of coffee, and there was a disease that was struck because of monocropping, that is coffee rust. Entire coffee population was wiped out, because monocropping is that much dangerous. At the time, people they don't know, but we now realize it, right? That is different. So then coffee rust, that coffee rust was struck it, and around 90 to 95% of the population is wiped out. And again, this Britishers shifted from coffee cultivation to tea cultivation. Again, there is another disease called tea blister blight, and another one more disease came strike it, and again all the coffee gone. Now they have shifted to rubber. Again, rubber is also in the danger now, like abnormal reap curl and other kinds. Here the thing is, we need to understand something. If there is only one crop, or if there is only monocropping is happening, if the disease occurs, or if the dangerous disease occurs, that's it. It will spread very rapidly, because the same kind of genes, same kind of crop, same kind of environment, everything is same, like, so it will spread very fast. That is the one prime reason where this coffee rust actually, who is the first person who identified the epidemiological reasons, or the epidemiology of this coffee rust fungus, is also one of the student of Anton de Berry. He is considered as the father of tropical plant pathology. Exactly. See, at the time, Britishers actually requested Anton de Berry when this coffee rust came, because at the time he was very famous. This is how history we need to study. You can simply study that. This, you cannot, put your effort on the history. What actually happened in the 1870s? Actually, in 1860, in the middle of 1860s, the Britishers identified there was some disease actually destroying all the coffee production. Then they wrote around 1867 or 1868 time, they wrote a letter to Anton de Berry, like because at the time he was a very famous mycologist. So they wrote a letter to Anton de Berry, and they requested Anton de Berry, like, there was something is happening, why can't you come and help us? Because at the time 1870s, because Anton de Berry at the time was very weak, and his health condition was not good, and he said that, okay, I can't able to come, but I will send one of my student. It was the Anton de Berry suggestion to HM Ward to go and take a look at what exactly happening there. With the suggestions of Anton de Berry, this HM Ward started to sail, because at the time there is no flights. Because when these flights came into existence in 1880s and 1890s, Wilbert Wright and Arvili Wright, right? Before that also there was another theories that Indians in 1870s and 1860s itself, the original theory was given by Indians. Okay, that is all the other theory. That's not at all necessary for us. Again, he started sailing and he went there. Sri Lanka, he was identified one important reason. Forget about the life cycle, all those things, because he made great contributions in the terms of life cycle, identifying the life cycle, that is different. But the thing is, he identified the environmental conditions are playing very important role. Another point is also added up, like monocropping is the very important reason that is destroyed. The reason for destroying the entire coffee rest is just, I mean, coffee population is monocropping, and the suitable environmental conditions, and other kinds of cultural practice, other kinds of things he have told. And one more new theory he gave, like bridging host theory. Like if you keep on continuing the same crop, like there will be a bridge formed, like the generation after generation, it will keep on continuing. Other kinds of things were told. That's why, because of the greatest contributions in identifying all these stuffs, he was denoted with the father of tropical plant pathology. Okay, anyway, that is different. But generally in the coffee rust, acial stage is absent. We cannot say absent, not identified so far. There might be there also, it was not identified so far. And if you see demicyclic lack of iridial stage, iridospores we can also call as repeating spores and can cause auto infection. Iridospores, repeating spores, it keep on repeating, multiple number of spores are produced, and again it can cause infection. I will show you. Yeah, you can take a look at this. This is iridospore, right? Iridospore reinfecting the wheat, and again it continues. So that's why iridospores is known as repeating spores. It keep on repeating and will infect, because the entire life cycle, this iridospore is generally considered as asexual spore. Of course, generally all other spores, you forget about all the other spores, but because why it is called as asexual, we keep on repeating, keep on continuing, because other spore stages are, if there is no situation for the other spore stage, this iridospore itself can reinfect the wheat again and can continue the life cycle, keep on continuing. That's why sometimes even the alternate host we can't able to find it. This iridospore can cause the auto infection. That's what is called as repeated infection. Okay, that is different. You forget about it. You coming back to this point, iridospores are considered as a repeating spores. As I told you, it can cause a repeated infection, and that is auto infection. Auto means automatic infection, repeated kind of infection. Okay, rusts are either autoecious and heteroecious, but in the case of wheat stem rust, it is purely heteroecious. Okay, so in the case of wheat stem rust, it is purely heteroecious, but other rusts are also there. There are fewer other autoecious also there. For example, you can take or uromyces causing diseases or uromyces genera. Most are falls under this autoecious rust type. But heteroecious means wheat stem rust. Okay, so the Romans created a festival, because we do study like Robigolia, everywhere Robigolia, right? So this Robigolia was actually created by the ancient Romans in order to protect their crop from the rust disease only. So at the time, people used to cultivate. There is no rice, other kinds of things. They used to cultivate, mostly used to cultivate wheat, rye, and barley. So there is a movie called Moon something. No. There is another movie like Rebellion Moon. Yeah. Rebellion Moon. So if you see that movie, you will understand like how the primitive people at the time, the tribal people were there at the time. Of course, it's a very advanced movie, but their tradition will reflect you. They'll show you. Just 1 minute. Huh? Yeah, joining very early. People are joining very early. Okay, so their like they used to cultivate wheat, barley, and rye, other kinds of crops also are there. But at the time there is no germ theory, nothing on all the stuff. But whatever that is happening, they used to believe that it is a cause of God, or it is happening just because of God. All the stuffs will be there. So to combat or to protect their wheat crop, they have created their own god called Robigus. They used to celebrate a festival called Robigoli, April 25th of every year. So related to this, we have in detail like Robigolia. So Robigolia was a very ancient festival of Rome that appears or prays to God called Robigus. So male god is called as Robigus. These all are questions only. Okay, Robigolia was celebrated against which disease? Rust, smut, leaf blights. All those things will be there. It is specifically meant for rust disease. Of course, couple of books it is mentioned that it is also used for leaf blades and other kinds of things. But the word Robigolia, that is especially denoted, or Robigus or Robigolia, is especially denoted to rust god only, because the rust pustules are red in color. The Robigus, god Robigus, is generally god of Jupiter. What is the color of Jupiter? Dark brown color or dark red color. So in that way, pustules are red, god is red. That is how they are symbolically representing it. So Robigolia is pure and pure. It is a representation of wheat stem rust. So might be it is also like leaf rust. I mean leaf related disease also might be there. It is a pure and pure of rust disease only. Male god is called Robigus. Female god is called Robigo, depending on the source. Okay. So there is a king called King Numa Pompilus. He is the one who erected celebrating this. Before that also this festival was there, but it became a tradition with this King Numa Pompilus around 700 BC. He made this festival as a tradition. It's been 700 BC before Christ to now 2025, around 2700 years. With the time, like borders are changed, traditions are changed, kings are changed, kingdoms are changed, everything is changed, but the tradition is still continuing. It's been 2700 years to now, still this tradition is continuing. You'll just go and type Robigolia in internet, like in especially YouTube, you will find couple of things still they are celebrating. In fact, in the last time, in the April 25th this year, I've also browsed something like what's exactly they used to celebrate. Still they are celebrating, but like traditions they keep on continuing. However we are celebrating our festival, holy, whatever it is, they keep on continuing this, even though like we do identify it is caused by fungi, but they keep on continuing this tradition. Okay, anyway, this was started by a king called King Numa Pompilus. It is mainly associated with the rust disease that is called cereal rust, wheat stem rust especially. No, right, okay, fine. So wheat stem rust especially. So the Robigus or Robigo is the Roman deity or the Roman god for especially rust and blights also it is mentioned, but primarily it goes to rust, especially wheat stem rust Puccinia graminis etc. So Romans or Robigus actually worshipped the civilization of Romans. It is also one of the king. Like they asked questions like Robigolia festival actually worshipped from or it is associated with the which of the civilizations, like which of the people, like Romans, French, like that also they will ask. It is also with the Romans. In a short way of remembering all this stuff, Robigolia associated with the god Robigus. The festival like celebrate against the rust disease. The king initiated is King Numa Pompilus. It is a Roman ritual. Romans used to do this. April 25th of every year we are celebrating in the modern times. They used to sacrifice red dogs. Why again red dogs? Again the color of the pustules is red. Robigus is the red color things you do, like blood is also red, right? And that way the symbolic representation. They used to have this red dogs. You can ask me why only red dogs. So because at the time in the streets, red dogs used to roam all the time, so that they used to get these red dogs very easily, so that they used to sacrifice these red dogs. Sheep, foxes, cows, every stuff they used to sacrifice. That's all about sacrification. Because if you sacrifice something, the god will cool down himself, and there will be no rust will come. But now we know that rust is not just because of god and all stuff. It is caused by fungi, Puccinia graminis. That is different, right? One other point, teleospores germinate without resting period is known as leptospore, because mostly teleospores undergoes a kind of resting spore, right? So sometimes the teleospores may germinate and produces promycelium immediately. That is generally known as leptospores. If the teleospore is getting no rest, or if the teleospore is germinating without any resting period, it is known as leptospore. Yeah. Now we will discuss. We have discussed a couple of things, right? Autoecious, heteroecious, microcyclic, all the stuff, right? So here autoecious, it is your duty. You tell me like one like what is this first one, like autoecious, macrocyclic. You just tell me the definition. Remaining things I will tell you. Okay. It starts with autoecious, macrocyclic.
Single host, all spores are present, all five.
Yeah, keep on continuing. Next one, autoecious, demicyclic.
Single host, uridospores are absent.
Please continue. Heteroecious, macrocyclic. Different hosts, 5 spores. Yeah. Heteroecious, demicyclic. Demicyclic means uridal stage is absent. Yeah. Example, exactly. So examples I have given. So entire life cycle, all 5 spore stages are complete in a single use. That is called autoecious, macrocyclic rust. Examples here. The examples are very important. Autoecious, macrocyclic rust examples are bean rust. Pathogens also important. Uromyces serpenticulatus. Flaxseed rust, Melamsora lini. Sunflower rust, Puccinia helianthi. Safflower rust, Puccinia carthami. Castor rust, Melamsora ricini. So these all are the examples of autoecious macrocyclic rust. So which means all the 5 spore stages are completed in a single host, that is called autoecious macrocyclic rust. The second one is autoecious demicyclic rust. So demicyclic means lack of iridial stage, but autoecious means without iridial stage, the remaining spore stages with the help they will complete the life cycle. Best example is rubus orange rust, Gymnoconia pekiana. We can also call it Gymnoconia nitens. Heteroecious macrocyclic rust, very important and the most important one. So hetero means different. The pathogen requires two biologically unrelated hosts to complete the life cycle. So that is called as heteroecious demicyclic rust. Sorry, heteroecious macrocyclic rust. So example is wheat stem rust, Puccinia graminis TTC, and white pine blister rust, that is Cronartium rubicola. These two are the examples. And heteroecious demicyclic, which means iridial stage is absent but the spore stage is completed in two different hosts. Best example is car. Car means not the driving car, that is different. Okay, for the shortcut I gave you car. Cedar apple rust, cedar C apple A rust R car, that's why I given like this. Okay, cedar apple rust which is caused by Gymnosporangium juniperi verzinane. This is the best example for heteroecious demicyclic rust. In exam they will ask which are this, by giving one pathogen, this is an example of which are the following rust type, like autoecious macrocyclic, heteroecious democyclic, heteroecious macrocyclic, autoecious demicyclic, like that they will ask. So these are all the very important examples. So mostly the questions like may fall from this section only. So take a look at it. And alternate host for cedar apple rust is generally apple, and demicyclic means lack of iridial stage. We have to discuss, right? Yeah. If you see this life cycle, this is one of the great picture, right? So this was drawn by one of my student. She have just recently finished her BSc agriculture from our own college. Anyway, so if you see this life cycle, I'm not telling you, like I will tell you in a simple way. We'll start with this Asium. Asium is coming and infecting, like it is penetrating inside through stomata and it is producing iridium. From the iridium, iridospores are coming and again it can reinfect the wheat and continue the life cycle. With the time and this iridospore again they will become a binucleate spore that is called as teleospore. This teleospore again they will produce from each teleum 4 number of basidiospores are produced, right? So again this basidiospores they will come and infect on this barberry. So if you see here iridium and teleal stage that happens in a primary host that is called wheat. In the barberry, this basidospore will go and infect, even though, like for example, if you see, if the iridospore and teleospore fall on the barberry, it will never germinate. Only basidospore can infect this barberry. Okay, so this is also one of the important. Which of the following spore can infect barberry? Only can infect barberry. In the options they may give iridospore, teleospore, pycniospore, or basidiospore. See, remember, basidiospore only can infect this barberry. From this basidiospore infection, again this will produce again germinates and it will produce on the upper side pycnia or spermatia, or pycniospores are produced on the lower side, it will produce as asia or asiospore or aedium we can also call. From again this asiospore, this will come back and will keep on infecting the life cycle. Primary is like, yeah please.
Sir, what is the mode of entry of basidiospore in barberry leaf?
Mode of entry means?
Means like asiospore, mode of entry is stomata.
Oh, okay.
Wheat.
Okay. So that, oh, you are asking how this basidiospore, like if you see in, I will show you one picture. General characters of fungi are fine. Okay. Yeah, take a look at this. The spore is coming and the spore is coming and landing on the leaf. From this spore again they will produce germ. Are you guys are there, right?
Yes, sir.
Yeah. Yeah. The spore is coming and landing on the leaf. So from this leaf, the spore starts to germinate by producing the germination tube. From this germination tube, there is a structure called aprosorium. From this aprosorium, there will be a penetration peg go inside. From this penetration peg, it is all like the whatever the process that we have discussed earlier, the same thing will happen. That this basidiospore will come and land on the leaf. Again, they will produce germination tube. From this germination tube, aprosorium is produced. From this aprosorium, ostoria, they will penetrate inside and they will produce all those things. So the procedure is same, nothing different. Okay, the basidospore will germinate and will produce aprosoria. From this aprosoria, it will be penetrating inside and will start to draw the nutrients hostoria. From that, again, this pycnium on the upper side, pycniospores, and lower side, achiospores are produced. This is how this process will happen. Okay, the same, however, what we have discussed in the beginning. Okay.
Okay, sir.
Yeah, fine. So, yeah, you remember 2 points here. One is iridium and teleal stage that happened in the primary host, that is wheat. Asium and pycnium and acial stage that happens in the secondary host or alternate host, that is barberry. Okay, so sometimes they do ask iridospore gen only, like for example, if you even though you inoculate this iridospores on the barberry, it will never germinate. You will take this basidiospore and you will try to inoculate on the wheat, it will never germinate. Okay, so iridospores and teleospores always germinate on the wheat. Pycniospores and achiospores always germinate or always produce infection or like things happening in this barberry only. Okay, so sometimes they do ask what is the sign. Yeah, please.
Sir, it means basidospore it enters through direct penetration, but achiospore they enter through stomata.
So the achiospore, when they are falling on the this leaf, like on the wheat, they will actually enter through stomata. Generally, this wheat stem rust pathogen enters through stomata.
Okay, sir. But basidospore they enter through direct penetration.
Yes, it was somewhat like that only. So here you need to understand something. The barberry leaf is different. The biology is also completely different from this wheat, right? So there the barberry spores, like if you this see, that's why here the morphological changing their forms is important, because if you see the leaf, so here it is a symbolic representation. I will show you one more thing. Here the leaf is very thick. The barberry leaf is actually very thick compared to the leaf of this wheat. Wheat leaf is normal, very thin if you compare to this one with the barberry. That's why the spores are keep on changing their form according to the adaptation, according to the requirement. That is the actual thing. I will show you one more thing here. For example, yeah, I have mentioned, like, I think especially normal kind of things only I have mentioned anyway. So anyway, here if you see here, this is direct penetration. Actually, generally it will germinate directly, however, what we have discussed in the beginning. But in the case of achiospore, when it is infecting or trying to infect this wheat, this achiospore actually germinates through the stomata, natural opening. Okay. And there are points like, if you see this wheat stem rust life cycle, so by mentioning one spore stage, they will ask this spore stage actually germinates, or which of the following stage can only infect wheat, or which of the following stages can only infect barberry. What is the spore that actually initiates the infection in the barberry leaves? Tell me, what is the actual spore that ignites the infection in the barberry leaves? Yeah, it is the yeah, that's why I'm telling you, it is a very complex. In fact, like even though if you read
Sir, that means achiospore infect the wheat,
achiospore,
infect to the wheat.
yes, achiospore actually infects the wheat. And one more thing is, exactly, that's what I'm trying to tell. Iridospore also can infect. That's why I'm telling you, it is a repeated infection. The iridospore, see, sometimes even though without iridospore, the infection can continue. How? Without achiospore, the infection can continue. How? Just now I told you, iridospore is a repeating spore. It can keep on repeating the infection. Yeah, exactly. That's what I'm telling. So not only achiospore, but iridospore also can infect and reinfect and keep on continuing the life cycle without producing the other thing. If the suitable host is available, it can continue, or else the same iridospore keep on continuing, and will produce keep on the same kind of infection. If it is an unfavorable time, it will produce teleospores. The if like for example, in the life cycle, you might have studied in the books, like there is no book where they have mentioned what exactly the life cycle is happening. If you see any book, there is no book that what they have mentioned exactly how this exactly life cycle in a step by step. They might have given you like 5 spore stages are present. They will mention something about the spore stages. But I wrote one newsletter, but I have not yet published it. I will show you that. There I have tried to deliver something like how exactly this wheat life cycle is happening. Just a minute, I will let you know. Newsletters, right? Just 1 minute. That's why I told you this. The class will continue up to 10:30. Just a minute. Wait, stem rest light. Okay, fine. Yeah, here I have tried to mention, it starts with this all the stuff, like the most complex nature of wheat stem rust pathogen is due to their life cycle. Here I have started it. The red to brown color rust pustules, uridia or uridinium produces iridospore, because wherever you see the life cycle always starts at one point, because wherever you start again you will keep on rotate and keep on keep finishing the same point, right? So I am starting here with iridospores because in India the infection is caused by iridospore because of our environmental condition. If you see the temperate areas like USA or maybe the wheat producing areas of Russia, there the infection is actually initiated by ASRB. Here the point came. ASRB can infect, but in India the infection. Yeah, please.
Voice is not proper.
Just a minute. So we need to start the life cycle somewhere else. So I do take little extra time. That's why I have given you like 8:30 to 10:15. It may extend to 10:30 also, because as I told you, wheat stem rust life cycle is a very important. I just want to tell you in detail. If you wish to listen, or else I will complete, like I will keep just telling the important points. I may finish it, like, okay. Anyway, for example, you can see here the red or brown color pustules, that is uridinia, actually produces iridospore and initiate the infection. In India, the infection was initiated by iridospore. For example, you can see the foreign countries like United States of America, or the temperate countries, are the wheat where the temperate, they are growing in a temperate regions. For example, in Russia, you can take United States of America and some parts of the wheat growing areas. There, the infection is actually initiated by the ASRB based on their environmental condition, especially the temperate condition. Because in India we do have all kinds of climate. Mostly we are comes under the subtropical, right? So anyway, so here in India it was initiated by iridospore. That's why I started with this iridospore infection. So it will produce, I mean, after iridospore infection, and it initiate the infection, and they will produce the symptoms, and like the rust pustules appears and the nuclear condition. All those things I have mentioned here, like not like all the spore stages, like however what we are studying, this is just giving the description about the particular point. For example, if you see here on all the most of the areas, they might have given you like this way, like pycniospore, how this, what is the characters of pycniospore, like spermatiospore characters of this ASRB characters of ASRB, that they might have given in this way. But I'm generally telling you, like, for to have the overall knowledge is very good, especially related to this wheat stem rust. But please remember, in India the infection was initiated by iridospore only. This ASRB can causes infection in a temperate regions, especially you can take UK, USA, or Russia, especially temperate regions where the wheat are growing, where this ASRB can cause the infection. But in India the infection is caused by iridospore, so the iridospore always initiate the infection. So that is the important point here. So with when the crop is at harvesting stage means what? Almost the crop is going to end, which is unfavorable time, because the iridospore cannot survive harsh conditions. So this is not exactly designed for it. This is designed for it a repeated infection. From this iridospore, because iridospore sense rate, this there is when the crop season is going to end. So the less number of iridospore and more number of teliospore production takes place in the uridinia, or that particular pustule. These teliospores are bicelled, which means dikaryotic, or we can also call it as diploid. So the bicell, right? So there are very thick. So that's why here we can see that thick walled cell is present. So these spores are especially designed or designated to survive the harsh environmental conditions. That's why I told you, like, they take some kind of rest or resting period. They undergo resting period because of unfavorable time only. This iridospore is converting into teliospore, right? So with the favorable time, sometimes the iridospore germinate immediately. So the spores can start to produce. From this teleum is considered as probasidium, the germinating. This is considered as metabasidium, that is promycelium is considered as metabasidium. From this sterigma will come. From this sterigma, this basidospores are produced. This is what we have discussed in the yesterday's class, like what is promycelium, what is probasidium, what is metabasidium, what is anabasidium, what is where meiosis takes place, where is karyogamy takes place. Now my question is, where in the basidia where the karyogamy takes place, where the karyogamy takes place. Where about, what about meiosis? Exactly. Define sterigma. Yeah, some small kind of hair like projections that happens on the basidia. above this sterigma or above this hair like projections only the basidospores are produced. Anyway, I just want to ask you one more point, like we are discussing or we are taking the classes from last 25 days or maybe 30 days, right? Almost 1 month, right? Are you guys are really getting like what I'm telling, or if there is any discomfort in terms of teaching, I'm asking. Like you guys are comfortable. If there is any problem with the teaching and understanding the concept, don't tell about other things. You just tell about whether it is catchable or whether it is easy to understand, whether it is okay or else is you guys want to change it. Is everything is fine, right? Everything you guys are understand.
No, sir.
Not understanding, huh? Please let me know, like, because you're paying and you're expecting some good quality content, again keep on continuing and without realizing that whether you are getting it or not, it will be like it's own good for you and as well as for me, because I'm actually doing it for satisfaction. So please let me know if there is any discomfort. If everything is fine, right? Everything whatever we are teaching is everything is fine, right? You are getting it right. Yeah, please answer for this question, man. Are you guys are there?
Yes, sir. Yes, sir.
Yes, sir. Good. Everything sounds good.
Yeah, everything is fine. Maybe 1 or 2 points might be difficult for like 1 or 2 points will be there, but I'm always trying to make this thing simpler and easier. So everything is fine. There will be no discomfort. If there is anything else, please let me know itself. Let me know now itself, because don't think that if we tell something sir may feel. I never feel, because I always need people who criticize me. I always need people who tell me or who point out me the wrong things, because the good things we are doing, that is different. I need someone who point out the wrong things. I need someone who tell me like this is not, that is this. Like there are a couple of members in our group, they used to point out the things. I really like that, because if you keep on telling sir you are doing that, this like this is not the way what I'm, you don't, like please tell me. So if you keep messages, I may not get it, because there is only one screen is running up here. Yeah, if it is if you are getting the points, I'm really very happy, because it's all about my satisfaction. Because I don't know whether how many you know that, but I really enjoy the teaching. I really love the teaching. That's why I'm doing for. It's all about satisfaction, not about your money stuff, all those things. Because whatever you're paying and all those things, that wherever it's going, that's not at all a matter to me. But I really enjoy teaching. So even though it's a hectic schedule, I still enjoy it, because as I told you, teaching is very important, very like. Very like mind relaxing part, or like I really enjoy and satisfy in terms of teaching. So that's why I am still doing this. That is different, but so it is like my duty to deliver as easy it is, like as simple I can make it. But it is also your duty if you're not getting it some points, like like if you're not getting it, if I'm going a little bit faster in the sense we need to go a little bit faster on. Again, if you leave me, I can keep on talking about 3 hours or 4 hours about wheat stem rest. It will keep on going, keep on going, keep on going. Like that's what I'm telling. Okay, anyway, so you are understanding and you are getting the points. So whatever the classes we have discussed, somewhat clear, right? There will be no problem in terms of teaching and understanding the points. That is clear, right?
Sir.
Yeah, fine. So anyway, thanks for that. We'll,
Yes, sir.
please. Yeah, thank you. So yeah, please.
I want to raise one issue.
Yeah, please.
It's not an issue, like, but I want something. I don't know what the other
Yeah,
speeds,
so
but
please.
I want the class to be somewhat speed. Means it's very slow and it is not completing in time. Because after coming from the lab or something, we have some other things to means the class means observations there. We have to follow up what are the fittings which we have done in the classroom that day. So if class ends at the stipulated times, we will get time for reading as well as follow upping our research works also. But since the class is dragging, we are unable to get the time for that work and even for reading. So I think class speed should be increased a bit.
Okay, thanks for that point. Actually, the thing is, I also thought that, because like 8:30 9:30 means I thought to finish it in that particular time. Again there will be points keep on coming it, and again we are going, like that's what actually happening. Anyway, we'll do one thing after mycology. We'll definitely keep exactly in time, like 8:30 9:30 means 8:30 9:30, because I know I always keep in time. But the only problem is, like, I just want to deliver as much as I know, like the whatever I know, like whatever the things I have collected, I just want to, I'm just spilling it everything, like if I'm preparing for not only net but also ARS, we don't know the points where they actually asks from. So that's why I'm like sometimes keep on increasing. One more point is, anyway, thanks for that, I'll definitely take into consideration. There is nothing wrong about it. I do understand, because everyone are busy in their other activities and all the stuff. Okay, anyway, the other point is, like, so if I finish in time, in fact, that is a better for me. Why should I again keep on increasing and raising, like half an hour extra, 1 hour extra? That will be actually taking extra calories. Now itself I'm too lean. No, again spending extra calories, right? I'm not thinking in that way. I'm thinking like delivering the exact thing. Again, like, if you keep on extending this point, like if you keep on goes, like, again, whatever we thought that we finish this the given syllabus, or whatever we promised in the beginning when you are joining, so we may not keep the time. That's why I'm just extending it. Anyway, I'll definitely take into consideration from bacteriology, not from mycology, because one more class left for mycology. So next class is all about anamorphic fungi. We'll finish anamorphic fungi. From the bacteriology onwards, I'll definitely keep time. 8:30, 9:30 means 8:30, 9:30. I'll definitely do that. But this let's just today and tomorrow, you please adjust, and from next time onwards, we'll definitely keep the time. Okay. Yeah. Anyway, we'll continue this. Yeah. So this is how this generally the picture is all about. If you see this, there are 5 spore stages are present, right? Pycniospores, Aciospore, Iridospore, Teliospore, and Basidiospores. Here the stages are designated to Roman letters. Pycniospore 0, Aciospore 1, Iridospore 2, 3, 4. Why this is actually named as 0? Why can't 5, or why can't 1? Why can't it is named as 1, 2, 3, 4, 5? Why it is named as 0? No, it's not about single cell or something else. Actually, this first, yeah, please. Yeah, please.
So initially, they thought this pycniospores doesn't have any role in the life cycle
Exactly.
of the, so they thought this to be kept in 0 stage.
Exactly. No. Actually, they thought that this Pickney has no role or no function. But when this Craig in 1827 or 1927, when this Craig identified the exact role of these pycniospores, which actually everything came from this. This is the true sexual stage where this everything is coming from, right? So rather than designating in the last, why can't we designate in the first? Because everything comes here, right? That's why it is designated as 0. Because the remaining spore stages, it was identified earlier. They have already named it 1, 2, 3, 4. Why again naming it 5? Rather than giving it 5, we'll give 0. It all starts with 0, right? So this is always the first one who actually initiated that. So before it thought that Pickney has no function, but later there is a scientist called Craig. I have given here, right? First discovered Craig the function of Pickney, and he also wrote a book called The Function of Pickney of Rust Fungi, I think. So he's actually a Canadian plant pathologist, especially he's a cereal pathologist. Okay. So we'll start with 1 spore stage, 0 stage, or we can also call as pycniospores or spermatiospore stage, or pycnial stage or spermatial stage. Pycniospore or spermatiospore are produced that bears spermatia and receptive hyphae. Spermatia from spermatia, spermatiospores are produced. We can consider the spermatiospores are male cells, receptive hyphae is a female cell in general. Okay. So the spore color of this pycniospore is hyaline, and it will produce monokaryotic gametes are produced from the spermagonia or pycnia. Generally pycnia are flask shaped, right? The first person who discovered the main functioning of this pycnia is Craig in 1927. It is a very important one. Okay, and this question was asked 3 to 4 times. If you take who reported the the function of pycnia of rust fungi, Craig 1927. If you take a look at this, this is actually, that's why I symbolically represented as a white color, because pencil is a little bit different, but generally without coloring I have represented as a hyaline color. So representation also, if you see, take a look at this, it is slight yellow in color or light orange in color. Generally Aciospores are yellow in color, right? So like that symbolic representation also we given here. Anyway, this is actually hyaline in color, produced on the upper surface of the barberry, and this stage was first discovered by or reported by this Craig 1927. The next spore stage is Aciospore, and exactly on the lower surface of the barberry. So please remember one more thing: pycniospores or spermatiospores or gyrospores are produced on the upper surface of barberry. If you see on the lower surface of the barberry, these Aciospores are produced. This surface also very important, because if you see in this iridial and teleal stage, they both are produced on the upper surface of the wheat. So if you see this pycniospores and achiospores, pycniospores on the upper surface of Barbary, achiospores on the lower surface of the Barbary. Anyway, coming back to this point, achiospores generally are actually produced from the diploidization of monokaryotic mycelium, right? And they produce matured acheous, or we can also produce achium or aidium in a chains. You can see here the chains of spores are can be seen here, right? So they are actually yellow in color. That's why I have symbolically represented this yellow. Another iridospore. So iridospore is a binucleate spore produced from the binucleate mycelium. This serves as a repeating spore. Repeating spores, as I told you, keep on repeating the infection. So without this, other spore stages also, it can keep on repeating the infection. In India, the the infection was initiated by this iridospore only. We can call it as repeating spore. Okay, also called as summer spore, also called as iridiospore, also called as iridospore, also called as red rust spore. These iridospores are produced in a structure called iridinia, or also called as iridosauri, also called as iridia. The spore color is golden brown in color. Okay. So Puccinia, they produces iridospores are called as amphispores. If the Puccinia producing iridospores are amphispores, so they were actually thicker, darker. They were normally iridospores only. Okay. So here iridospores, otherwise called as repeating spores, otherwise called as summer spore. The nuclear condition is N+N. They are golden brown in color. They are single celled. A specific fungicide recommended is oxycarboxyn. You can recommend for street treatment. You can also use it for spraying as well. The trade name of oxycarboxyn is plant wax. So please take a look at it. Very simple. Rust, they will produce iridospore. Repeating spore, iridospore is known as repeating spore. Summer spore, N+N, golden brown, single cell, oxycarboxyn. Everything is finished here itself, right? Next one is teleospore. They are binucleate spore produced from the dikaryotic mycelium. The teleospore represents actually the true dikaryotic condition. N+N we can also call as diploid. The true dikaryotic condition is actually represented, or true diploid phase actually starts with this teleospore. Through this karyogamy will happen. Okay. The spore color is generally black or sometimes dark brown in color. Mostly we can call it as black in color, but it is also generally dark brown in color. Okay. So this teleospore also called as teletospores, also known as winter spores, also known as black rust spore. Now the question is, who coined the term teleospore? Who coined the term? Exactly. Anton de Barry coined the term teleospore. He coined teleospore as a teletospores. See, all are same only. Teletospores, teleospores, winter spore, all are same only. Teleospores or teleospores, like spelling also sometimes Teleospores, teletospores, teleteospores, all are same only. This is representing the teleospores only. Okay. Smut generally produces teleospores. Of course, rust also produces, that is different. Teleospores are generally known as resting spores. We can also call as winter spore. It is exactly opposite to this iridospore. Iridospore is commonly called as repeating spore. Here teleospores are resting spore. Iridospores is commonly called as summer spore, but teleospore is called as winter spore. But iridospore here at N+N only. With this teleospore we can also exist in 2N condition, that is diploid. Okay. So there they're golden brown, here black or dark brown in color. They're bicelled, they're single celled. Teletospores, carboxyn. There oxycarboxyn is recommended for rusted diseases. Here carboxyn is recommended for smutty disease. We can also the trade name of carboxyn is Vitavax, or we can also call it as Vitavax. Okay. Yeah, teleospores are generally representing the resting spores that survive in the overwinter, but in some species teleospores germinate soon after the formation. Here there is no difference here, remember. So once this is the teleospore, sometimes they germinate immediately, or sometimes they may go under resting period. If they germinate immediately, from this teleospore they will produce this promycelium. From this promycelium 4 basidiospores are produced. Now from this basidium sterigma is also produced, right? So promycelium, from this promycelium, see this is teleospore, another structure will come, this is called promycelium. From the promycelium, see this is teleospore, something will come, this is promycelium, this is sterigma. From the sterigma 4 basidiospores are produced. Each basidiospore is uninucleate, right? 2 is plus, 2 is minus. So here the question is, remember the genus Puccinia graminis produces how many number of basidiospores from the single teleospore? If the single teleospore is germinating, how many number of basidiospores are produces?
8 number 2.
Exactly. There is no confusion. There are 2 cells are there. From each cell 4 basidiospore will come, right? There are 2 cells are there. 4 plus 4, 8 number of basidiospore. There is no confusion. Then again, sir, initially you told that from each basidium 4 number of basidiospores will come. Of course, from each basidium 4 number of basidiospores, here 2 cells are there. You can consider 2 cells, right? From each cell 4, 2 cells are there. 4 plus 4, 8 cells, right? So like that, okay? So actually this entire rust genera mainly identified based on the teleospore characters only. Based on the teleospore characters only, all the families we can easily identify. So we'll see, yeah, this is one question. Each teleum of Puccinia graminis tritici produces how many number of basidiospore? 8. For example, this is a teleospore. 2 cells. From each cells 4 basidiospores will come. 4 plus 4, 8. This is how it will work. Last one is basidiospores. They are haploid, uninucleate, thin-walled, short-lived spore. They are exogenously produced. Exogenously means outside, endogenously means asci. So okay, produced and a basidia. So basidium is also known as basidia, also known as basidium, also known as promycelium, also known as metabasidium. All are same only. Promycelium, so promycelium or metabasidium or promycelium or metabasidium, all are parts of this basidium only, right? From this basidium again they will germinate, they will produce promycelium. From this promycelium, metabasidium will come, sterigmata, all these things will come. Generally the spore color of this basidiospore is hyaline color. So without as confusion, there is a short thing given here. So all those things are represented here itself. Pycnospores are stage 0, they will produce one germ pore. Germ pore means germination pore, nothing else. Okay. So the color is hyaline and the condition is haploid in condition. They are produced, pycnospores are produced on the upper surface of barberry. Aeschiospore, the stage is 1. Germ pores are 6. The color is yellow in color. They are dikaryotic, N plus N. They produced on the lower surface of the barberry. So here they will also ask like, so which spore they will produce on the pycnospore actually produce on the upper surface of barberry. You can take aeschiospore, they actually produce on the lower surface of the barberry. You please remember these 2 points, okay. Another important point is like if you see iridospore stage 2, 4 number of germ pores are produced, golden brown in color, dikaryotic N plus N, upper surface of wheat. Teleospore again 3, 2 germ pores are produced, black in color, dark brown color, N plus N, or 2 in condition, upper surface of wheat. Basidiospore stage number 4, only 1 germ pore is produced, hyaline in color, that's why we have discussed, right? Pycnium and Aeschyum is hyaline in color, haploid, both are existing haploid. That they actually survives in the soil debris or inactive form for some time. So if there is any doubt in this, there is no doubts, we'll go further. Yeah, here given one more thing, rust, iridospore, repeating spore, summer pore, N plus N, golden brown, all those things I have given, we have already discussed it. There are some types of teleospores are there, like if you see like single celled teleospore, uromyces, like there are genera, single celled teleospore, uromyces, melomsora, pacospora, double celled teleospore, Puccinia, gymnosporangia, multi-celled teleospore, phragmidium, turnip shaped or napiform teleospore, kidney shaped iridospore or humpy-beak iridospore, hemilia. In the 2 classes or maybe couple of classes before when we are discussing this one, Sauvik asked a question, sir, in one book it is mentioned that turnip shape, not turnip shape. Turnip shape is supposed to be iridospore, right? So Sauvik, is the same thing you asked me, right? Are you there?
No, sir.
Yeah. So I have sorted out. I have gone through all the very good books and I have sorted out. So whatever I have mentioned is right only. Turnip shaped teleospore. Of course, teleospore is turnip shaped only. I will show you. Take a look at this picture. So here the characteristics of turnip shaped teleospore of hemilia. Take a look at this, napiform or turnip shaped teleospore. This is one of the very good article that was published in Nature. Second one, genus hemilia, you can take teletospore. Teleospores are turnip shaped. Take a look at this, teleospores are turnip shaped. Another important point, this is very good book, like this book is K.R. Anuj and Mehrotra book, the 3rd edition of Introduction to the Mycology book. They also mentioned. So the teleospores are produced on the same sorus under turnip shaped. Take a look at this, turnip shaped, which means teleospores are turnip shaped only in the case of genera hemilia. Okay, so turnip shaped or napiform teleospore or kidney shaped iridospore, or kidney shaped we can also call as humpy-beak iridospore or reniform iridospore, that is produced in the hemilia. Crust like teleospore, melomsora, parachute like teleospore, ravinelia. These are all the types of teleospore, how exactly they look like. You can take a look at this. This is a single cell, there will be multiple cells, double cell, 2 cells are present, multiple cells. If you see inside, multiple number of cells are present, phragmidium, parachute like ravinelia, because they look like a parachute, like a military parachute. They look like, it is called as parachute like teleospore. Hemilia, 2 things are there, kidney shaped iridospore, turnip shaped. They look like turnip shaped teleospore. Both things are there. Melomsora, crust like teleospore. Why it is named as crust like? Because however our soil is connected to like crust on crust, there are stratosphere, like sorry, there are some earth layers will be there. They're connected on one on crust, one on one, right? Like that in the stereospores are, sorry, the iridospores are connected one by one, one by one. So that's why, so the stereospore actually connected one on one. That's why it's called as crust like. They're attaching actually one on one, one on one. So that's why it is known as melamsora. Now, just 2 minutes, we'll finish it something. Just a 1 minute. So here, what are all the another point you need to keep it is, you tell me one important disease that is caused by the particular genera. Tell me one important disease that is caused by Euromyces genera. Euromyces.
Chickpea rust.
Yeah, Euromyces
Bean rust.
append. Yeah, bean rust, Euromyces appendiculosis. Yeah, P rust also. Melamsora, melamsora. Linseed rat, melamsora, gene for gene hypothesis. Pacospora.
Soybean rust or cotton
Yeah.
rust.
Yeah, there are two rusts are there in soybean. Asian soybean rust and another soybean rust is there. Asian soybean rust is caused by salonimetal. Yeah, Pacospora pacarize. What about Pacospora miabimiae? Miabomiae.
World soybean rust.
Yeah, old soybean rust, a general soybean rust is caused by Pacospora miabomiae. In Asia, especially in the countries of Asia, you can take Russia, you can take China, you can take India, all the couple of Asian countries where this soybean rust is caused by Asian soybean rust, or generally called Asian soybean rust, which is caused by Pacospora pacarize. Okay, yeah, Puccinia. Tell me one disease caused by Puccinia.
Wheat rust.
Yeah, wheat rust. Gymnosporangium. Yeah, Gymnosporangium.
Apple cider rust.
Yeah, cedar apple rust caused by
Gymnosporium juniper.
Gymnosporangium juniperi virizina. Phragmidium.
Rose rust.
Rose rust. Phragmidium mucronatum. Hemilia.
The coffee rust.
Coffee rust. Hemilia vastatrix. Melamsora.
Linseed
Melamsora.
rust.
Yeah, Ravinilia. Ravinilia. Yeah, there was one rust. I think fig rust something. There is fig rust or something like that. There is Ravinilia. Just 1 minute. Hello. Yeah. Yeah. Sorry. 5 minutes. I'll get you back. 5 minutes. Yeah, please. Oh, okay, fine. So here the thing is, it's all about teleospores. Anyway, forget about it. Yeah, I think there are few other slides are there. Maybe it will take another half an hour. So we'll do one thing. If it is okay, we can continue for another half an hour, or else I will take tomorrow morning 6:30 to 7. Again, there will be a class at the night. So what we will do? So, so what we have finished yesterday is about teleospore, right? So we have finished with this, like single cell teleospore, double cell, along with the examples also we might have discussed, right? And one more thing, like we have discussed, right? Generally, it is teleospore is generally turnip shaped in hemilia, and other things we have discussed. Yeah, from here we'll continue and we'll finish it. Generally, so two general terminologies we might have studied here. One is alternate host, second one is collateral host. Alternate host means generally the pathogen requires two different hosts which is belonging to two different families. Collateral host means the pathogen requires two different hosts but they are belonging to same families. For example, this alternate host is also known as alternative host. I repeat, alternate host is also known as alternative host. For example, you can take barberry, like wheat stem rust. Wheat stem rust requires alternate host as barberry. So barberry and wheat are different families. That's why I mentioned alternate host is a host which where they're belonging to mostly different families. So collateral host or alternative host, mostly they belonging to same families. Okay. Here I have given some alternative host of rust disease and along with the other pathogens as well. You take a look at here I have given disease name, pathogen name, primary host and secondary host. Secondary host is alternative host. First one is we will start with this alternate host. Wheat stem rust caused by Puccinia graminis triticale. The primary host is wheat and the secondary host is barberry. The scientific name of barberry is Barberries vulgaris, or you can also call it Berberis vulgaris. Okay. Wheat leaf rust, otherwise called as brown rust, Puccinia rigondita. Primary host is wheat and the secondary host is Thalictrum species and Isopyra, and one more species Mahonia is also there. And sorghum rust, Puccinia purpurea. Primary host is sorghum and the secondary host is sleeping beauty. The host name itself is sleeping beauty. Oxalis carniculata. It is a very important. Mostly the primary hosts are the same crop. For example, wheat, if it is a wheat rust, The primary host will definitely be wheat. If it is a sorghum rust, primary host is a sorghum. If it is a pale millet rust, primary host is pale millet. If it is a maize rust, primary host is a maize rust. Alternate hosts may change. Hope you know, right? So pale millet rust, Fucsinia substrata, primary host is pale millet, and the secondary host is a brinjal. Maize leaf rust, primary host is, causal organism Fucsinia sorgi, primary host is maize, and the secondary host is oxalis. So white pine rust, Cronatium rubicola, primary host is currant, and the secondary host is pines. Cedar apple rust, Gymnosporangium juniperei virginane, primary host and secondary host is mostly apple, and some other species of currants is also act as a alternate host. And crown rust of oats, Puccinia coronata, primary host is oat and secondary host is buckthorn, rhamna species generally. So these are all some, alternate hosts of the pathogen. Alternate host is alternate host is what? Like the host which is belonging to different families of the different family, which is actually different from the primary host. You can see wheat is belonging to Poaceae, but barberry is belonging to Barbaraceae. Like that, all primary hosts and secondary hosts are different family. That's why it's called as alternate host. Alternative, if not this, that one, like that. Here I have given some collateral host. Collateral host is also known as alternative host. Mostly they belong into same family of the primary host. So collateral host is a host where, or alternative host where they belonging to mostly the same family of the primary host. For example, you can see rice blast, which is caused by Pyracularia varice or Magnoporthia varice. Primary host is rice, and the collateral host or Lersia or alternative host is Lersia hexandra. So Lersia hexandra is a grass species which is also belonging to the same family, Poaceae family only. You can take bacterial blighter, BLB of rice, Xanthomonas varice, Pathovar varice, primary host is rice. You can take alternative host or collateral host, Lersia hexandra. Lersia hexandra, this is a grass species. Cyprus rotundus, this is also a grass species. All are belonging to Poaceae, which means they primary host and secondary host, they mostly belonging to the same family. Okay. Here, what we need to remember is just the alternate host and the collateral host of the given pathogens. Okay. Downy mildew of maize and sugarcane, Pernoschlerospora piripensis, Pernoschlerospora sagari. In fact, there are 12 species or 12 pathogens are associated with the downy mildew of maize. So generally primary host is maize and sugarcane, and the secondary host is sorghum alafins, sorghum bicolor, Saccharum spontaneum, which they are also belong to the same species, same family, right? So downy mildew of, or green ear of combo, Sclerospora graminicola pathogen, and the primary host is if it is a bajra downy mildew, bajra. If it is a kambu downy mildew, kambu. If it is a pale millet downy mildew, pale millet. But the collateral hosts are echinocola and panicum repens. They are also Poaceae species, right? Sugarcane whipsmut, which is caused by Sporosorium cetamine. Now my question is, what is the previous name of this sugarcane whipsmut? What is the previous name? What is the causal organism of this sugarcane whipsmut? Now I told you one causal organism, that is Sporosorium cetamine. What is the previous name? Are you guys are there or slept?
Yes, sir.
Okay. So what is this previous name of sugarcane whipsmut? Now I told you one, Sporosorium cetamine. There is one more name is there, previous name. Exactly. Ustulognocetamine. So later name change to Sporosorium cetaminium. Okay. So anyway, primary host is sugarcane, secondary host is Saccharum spontaneum. So I know it will be little bit difficult in the morning session, but just we will finish it up as soon as possible. Okay. Yeah, these are all the list of important genera that is caused by these are all the important list of disease that is caused by rust genera. So in the beginning, I told you majority of the rust diseases are around 75% or that to 75%. In the 75% of the rust diseases, 95 plus percentage of the rust disease that is caused by rust genera alone. Sorry, Puccinia alone. If you see the all the disease that is caused by rust, majority of them are falls under Puccinia only. You can take a look at this. So we'll go one by one. Wheat stem rust, Puccinia graminis triticina, brown rust, Puccinia triticina. So these questions, like in exams, they do ask maybe one causal organism. They may ask like what disease it causes, or else they may ask by mentioning one disease, what genera it is responsible for the causing disease. Like that, they may also. So orange rust or yellow rust, which is caused by Puccinia striata. brown rust of sugarcane Puccinia melanocephala, orange rust of sugarcane Puccinia cuni, hollyhock rust Puccinia heterospora, white rust of chrysanthemum Puccinia horrida, sunflower rust Puccinia helianthi. Like that, I have given the list of important diseases that is caused by Puccinia. In fact, there are plenty of other diseases also there, but these are all the most important and repeatedly asked questions. Okay. Other diseases include, as I told you, Puccinia is the genera which causes more number of diseases. After Puccinia, what is the genera that causes diseases, like more number of diseases? Followed by exactly Euromyces. Euromyces causes followed by Puccinia. There is another genera called Euromyces which causes diseases here, right? So there is only one disease in Hemilia, that is coffee rust, which is caused by Hemilia vastatrix. So which stage is absent or which stage is not identified so far in the coffee rust? Which stage is absent or not identified so far in the coffee rust? We have already discussed. Exactly, axial stage. Axial stage is absent or not absent. It is not identified so far. Okay. So another genera is Euromyces. It is the second largest genera after Puccinia. It causes more number of diseases. You can take all Euromyces like bean rust, Euromyces appendiculatus. So this bean rust comes under what type of life cycle? Like autoecious macrocyclic, autoecious heterocyclic. What it is? So, exactly. Yeah, BFSSC, right? Bean rust, flaxseed rust, sunflower rust, safflower rust, all are comes under autoecious macrocyclic rust. So which means the pathogen completes all 5 spore stages of life cycle in a single host. Okay. Bean rust, the pathogen is also important. Please take a look into Euromyces appendiculatus, gram rust, Euromyces caesari, peanut rust, Euromyces fisi, or you can also call as Euromyces fabi. Carnation rust Euromyces dianthe, jasmine rust Euromyces hapsoni, alfalfa rust Euromyces striatus var medicagnis. So this is about Euromyces. Melomsora, linseed rust, which is caused by Melomsora lini. This Melomsora lini is very important. What kind of teleospore it produces? The kind of teleospore produced by Melomsora. The kind of teleospore, is it audible? Kind of, yeah, kind of. Exactly, crust-like teleospore the pathogen produces. So Melomsora produces crust-like teleospore, and it is also the pathogen that is associated with the discovery of gene for gene hypothesis, right? And the Melomsora like popular rust, medusae, that is Melomsora medusae, castor rust, Melomsora ricini, Vavillo rust, Melomsora epita. So these are all a couple of Melomsora rust. And if you see another genera like Pacospora, we have already discussed, right? Soybean rust is caused by Pacospora pachyrizi. Asian soybean rust is caused by, sorry, Pacospora, Asian soybean rust, Pacospora pachyrizi. There is one more soybean rust which is caused by Pacospora miyabumi. So in Asia, Shivani, you can please mute your mic. Yeah. So in Asia, Asian soybean rust is caused by Pacospora pachyrizi. In world level, the soybean rust is caused by Pacospora miyabumi. Okay. Another thing is cotton rust, Pacospora gossipi, grapes rust, Pacospora uvitis. Okay. And another genus is Phragmidium. What is the type of teleospore produced by Phragmidium?
Multicelled.
Yeah, multicell teleospore Phragmidium. Okay. Example is rose rust, Phragmidium mucronatum, raspberry rust, Phragmidium rubiidea. These are all the couple of rust. Gymnosporangium. What is the kind of teleospore produced by Gymnosporangium?
Double celled.
Exactly. So no, double celled. This one, double celled teleospore is produced by Puccinia.
So gymnosporium is also produced.
Take a look at this. Yeah, that's right. That's right. Anyway, fine. So Gymnosporangium, that is also double celled. That's right. Anyway, thanks for that. Yeah, Gymnosporangium cedar apple rust, which is caused by Gymnosporangium juniperae verizinane. Ravinelia gooseberry rust. So Ravinelia produces what kind of teleospore? Parachute-like teleospore. Okay. Gooseberry rust, which is caused by Ravinelia emblica, Cronartium white pine blister rust, Cronartium rubicola. So these are all a couple of important things. Give me an example of heteroecious macrocyclic rust apart from this wheat stem rust. Apart from the wheat stem rust, give me one more example of heteroecious macrocyclic rust.
White pine blister rust.
Exactly, white pine blister rust, which is caused by Cronartium rubicola. We have discussed it, right? Anyway, so apart from the other terminologies, there are few things are there, like based on the absence of their stages, rust stages, spore stages. So 0 means Picnia or Picnial stage, 1 means axial stage, 2 means iridial stage, 3 means teleal stage, 4 means basidial stage, we know. So if the iridial stage is absent, what kind of cyclic rust it is? Iridial stage is absent. If the iridia is absent, exactly, demicyclic. I think everyone are in a sleeping mode. I will wake you up, don't worry. Anyway, so U type means there are some types are there rust based on the presence or absence of their stages. There are some types are there. U type means 0, 1, 2, 3 is present but 4 is absent. That is called U type. U type means 4 is absent. Brachy type 0, 1, 2, 3 is present but 1 is absent. Opsis or Opsis type 1, 0, 1, 2, 3 is present, 2 is absent. Hemi type 2 and 3 is present, 0, 1 and 0 and 1 is absent. Micro type only 3 present. Leptotype only 3 present. So micro and leptotype means only 3 present. So like this, this kind of questions I have never encountered, but some entrance exams we may do expect. As I told you, this is not only for net but also to make you well versed in the field. So these are all the some types of rust based on the presence or absence of spore stages. Yeah, genus Puccinia, it is actually named from Italian botanist. There is a scientist called T. Puccini. So, to represent the scientist or to honor the scientist, there is a new genera was created, Puccinia. So, it is actually derived from Italian botanist Puccini. Okay. So, Melamsora lini, this is associated with the gene for gene hypothesis. So, gene for gene hypothesis was given by H.H. Floor, 19, exactly. H.H. Floor, 1946. For every resistant gene in the host, there must be a corresponding and avirulence gene in the pathogen and vice versa, right? So that is called gene for gene hypothesis. Yeah, each basidium generally contains how many number of basidiospore? Each basidium contains 4 number of basidiospore. But there are, however, in the Ascomycota, each ascus contains 8, right? There are some exceptions are there. You can take Trichoderma, 16. So like that, Neurospora, Tetrasperma, 4. Like that, there are some exceptions are there. When it comes to Basidiomycota group of fungi also, there are a few exceptions that we will see. 4 basidiospore each basidium contains, that is majority of the Basidiomycota group of fungi. For example, you can take some exceptions like 9 number of basidiospore is also produced by fungi like Phallus impudis. 2 to 8 number of basidiospore, in between 2 to 8, this is produced by Exobasidium vexans. Exobasidium vexans causes what? What disease this Exobasidium vexans causes? Sorry? So Exobasidium vexans, I think it causes a disease in T, right? Yeah, it's supposed to be T blister blight. I think T blister blight. Why confusion? Just like we'll see. Anyway, I'll finish it up exactly 7:15. Don't worry. We have still 15 minutes left. 15 minutes more than enough. Exobasidium vexans. Yeah, it causes T blister blight. That's right. T blister blight is caused by Exobasidium vexans. Anyway, coming back to this point. Yeah. So 8 to 16 number of basidiospore Tilicia caris, 14 to 30 number of basidiospore Tilicia controversa, and 32 to 128 number of basidiospores is reproduced by Tilicia indica. Okay. So there is another race related to wheat stem rust that is called Uganda 99. UG 99 means because this race was first identified in a country called Uganda and identified in the year 1999, which means actually it is identified 1998 only, but the full description and full scale research was started in 1999. That's why it is given as Uganda 99. Okay. So this is actually first identified Uganda 1999, where it is named as Uganda 99. Though it is originally related to the wheat stem rust, it is a rate called TTKSK. Okay. So this Uganda 99 is actually virulence. This is producing virulence against the most resistant gene in the breeding, especially wheat breeding, that is SR21. Actually, this gene is highly resistant to all the existing races of wheat stem rust pathogens. But this Uganda 99 actually targeting this SR21 pathogen only. SR31 gene, sorry. SR31 gene is the most virulent and highly evolved gene in the resistant breeding of wheat. So this Uganda 99 is actually targeting this SR31 gene. Okay. And sometimes they do ask which gene this Uganda 99 will target. It is SR31. Okay. and TTKSK original, so TTKSKT virulent to SR24, like that there are some multiple variants are given here. It is not necessary, forget about it. And the father of Indian rust is like KC Mehta. So KC Mehta is considered as father of Indian rust, right? So Uganda 99, UG 99 reported in Uganda 1999. That is a virulent race or multiple like that. The variant is TTKSK, and it break down the resistant of a gene called SR31. So it is a global threat. Yeah, Norman E. Borlaug actually warned, before he warned about this Uganda 99 or existence of Uganda 99. E.C. Stockman, it is supposed to be E.C. Stockman. He introduced the concept of physiological resistance of rust fungi. BGRA, Borlaug Rust Initiative, Global Rust Initiative, is a major rust program that combats rust diseases. There are two major international research institutes continuously working on this. This is SIMMIT, simply I would say the International Center for Wheat and Maize Research, located at Mexico, right? And ICARDA means international, what is this ICARDA, actually I forgot. International Center for Arid Crop Research Development, whatever it is. So ICARDA, it is also one of the organization where they are working. SIMMIT means International Center for Wheat and Maize Research. Let's see what is this ICARDA. International Organization for Dryland Areas. Okay, fine. So this is also working in the combating, developing this resistance against this wheat. Just a minute. Yeah. Yeah, another thing is like this BGRA, Borla Global Rust Initiative. They are they developed something like rust spore, so which is kind of monitoring program, like how it is the rust, it is tracking, like it is going, like where it is causing infection and all those things. It is kind of, I would say, a computer simulation model, like forecasting model. It was developed by BGRA rust spore. So it was developed by FAO, Food and Agriculture Organization, SIMMET, and ARS Agriculture University, that is a university. This all combined and developed a program called Rust Spore, so that monitors this Uganda 99, especially this Uganda 99 race. Not only Uganda 99 race, but also other races of the wheat rust. But especially it is concentrated on Uganda 99. Okay. And there's also some common questions like which gene confers the resistant against Uganda 99. So which they're asking resistant against. So SR25, that gives you partial resistance, not complete one, partial, but it defeats a gene called SR31. Okay. Uganda 99 first reported in a country called Uganda, and which organization that UG 99 Global Threat is completely monitoring, like completely involved in BGRA, Borlaug Rust Initiative. Now we'll see about Mycology. That's it. This is the end. So Mycology mostly will study about smut disease and as well as bunts, right? So if you see all these smuts, there comes under Mycetes, and the word this smut, this Mycetes is actually derived from Eustillus. So Eustillus generally means burned appearance. Burned appearance means it is actually representing the black color appearance of the infected plants, especially the infected inflorescence. If you see infected inflorescence or the grains are converted into black color charcoal powder, right? So to represent that, it is named, it is given as Eustillus, which means burned appearance. So the smut is more dangerous than rust disease, because rust targets this maybe leaves or maybe stems or some other parts, but this is smut directly targeting this inflorescence. Sometimes it is also infect embryo, but very rare cases, mostly it infects inflorescence only, and growing shoot, and also responsible for the systemic infection. That's why it is more dangerous and it causes more damage than rust disease. So if the rust will occurs, at least you will get 10-20%, at least I'm telling, at least. So if the smut occurs, you will get nothing, everything gone. Like all the infected inflorescence is converted into black color charcoal powder or black color powder. You will get nothing out of it. Even though 1 or 2 grains left over, you cannot eat it, right? So why? Because it is directly targeting inflorescence or sometimes embryo and responsible for the systemic infection. That's why it is very dangerous. And the spores may be survive in soil or plant debris, or sometimes also with the seeds as well, and germinate by forming the germ tube. So that germ tube, you know, it is a promycelium, we can also call as metabasidium. Meiosis occurs in nuclear forms, and 4 number of uninucleate spores are produced, that is called sporidia. Don't confuse, sporidia means basidiospores only. In smut it is called as sporidia. So each basidium contains how many number of basidiospore? 4 number of basidiospore. The same way here from basidia it is germinating, it is producing promycelium. For example, you can take teleospore, this is teleospore. Teleospore is germinating, the germinating teleospore produces promycelium. From the promycelium sterigma will come, the sterigma will be its basidiospore. The same thing, from this promycelium 4 spores will come, the spores called sporidia. But here the method of germination is different. For example, you can take this is a spore, yeah, this is a spore. They will germinate in this way, like horizontally germinate in this way, where the spores are produced like nodes, like this they will produce. So each node there will be one spore. Those are all generally called as 4 spores are only produced. Those are all generally called as sporidia. Sporidia equal to basidiospore. You can also remember it as a basidiospore, but generally the spores produced by this smut are generally called as sporidia. Okay, the sporidia is basidiospores only. Okay, the important genera comes under this smut is like Ustilago, Spatilotheca, Toliposporium, Melanopsium, and Sporosorium. These are all the couple of important genera. Here I have given just basic information about this genera. Like Tilicia, it was named after Matthew Du Tillett, and think in the history we might have discussed, like he's the scientist who primarily worked on the bunt disease of wheat, right? And is also recommended like using of salt solution, other kinds of things. So to remember this Matthew Du Tillett, this Tulsen brothers named the genera as a Tilicia to honor Matthew Du Tillett. Okay, and bunt causing genera, for example, you can see the bunt causing genera mostly Tilicia, Neovesia, these all are classified under this Tiliciales or Tiliaceae. Okay, so this is generally the Tilicia is mainly associated with the bunt causing diseases. Teleospores are mostly single, and they produces spores are dusty, escaping at maturity. And one more important thing is they produces H-shaped sporidia. This question was asked in 2018. So what is the shape of sporidia that a Tilicia pathogen produces? H-shaped sporidia, because once it germinates, it will produce a H kind of sporidia. I will show you at the end of this lecture. Another genera is a Neovesia. Teleospores are single and also produces spores are dusty and escaping at maturity. And sporidia do not fuse, and the H-shaped sporidia will be not observed in this Neovesia. But in the case of Tilicia, H-shaped sporidia is observed. But in the case of Neovesia, no H-shaped structure or H-shaped sporidia. Urocystis, another genera. Teleospores are appears in balls. Sora is dusty and surrounded by a small layer, and spore balls escape from the sorus. Another thing is Ustilago, which is responsible for, there is a fungi, or we can also call as a maize mushroom. So this is actually Ustilago maedis or Ustilago GA. So which is generally called as Kutla Kochi or Hotla Kochi, because Mexican people used to have this mushroom. It is actually a disease. Okay, Ustilago maedis or Ustilago GA. This is also known as maize mushroom, because the people in the Mexico and the surrounding parts of the Mexico, they used to have this infected kernels or the infected maize. So because of their delicacy, because it's one more thing is in Mexico, they're doing cultivation and they're purposefully infecting and harvesting at the exact stage to get the delicacy, because so they'll also produces hypertrophy and hyperplasia kind of symptoms, mostly hypertrophy kind of symptoms. So that they are harvesting and eating. This is used for eating purpose. And one more thing is this maize mushroom, this Kutla Kochi, it is actually close to 43% equal to the genome of our human being. So this is also another important point. And these are all the different smut genera and diseases caused by them. You can take Ustilago, loose smut of oats, Ustilago avini and Ustilago segetum. Gigiana rust, Ustilago esculenta, covered smut of barley, Ustilago hardy, corn smut, Ustilago maedis, wheat loose smut, it is a very, very important one, Ustilago nodotriticea. So what is the nature of spread of this Ustilago wheat loose smut? What is the nature of spread of this wheat loose smut pathogen? Nature of spread of wheat loose smut pathogen. Yeah, so it is an internally seed-borne pathogen. So it is a seed-borne pathogen and spreads through internally seed-borne. It is visible, audible, right?
Yes.
Yeah, fine. So wheat loose smut is the best example of internally seed-borne pathogen. Very important one. And Sporisorium whip smut of sugarcane, previously it is called Sporisorium cetaminium. Sorry, now it is called as Sporisorium cetaminium. The previous name is Ustilago cetaminium. Okay. Grain smut of sorghum, Sporisorium sorgi, Spatialotheca sorgi. Head smut of sorghum, Sporisorium reliana, previously Spatialotheca reliana. Long smut of sorghum, now it is called as Sporisorium cruenta, previously it is Spatialotheca cruenta. And other kinds of smut disease, Microbotrium, anther smut, Microbotrium violacea, and this is important one. Toliposporium, long smut of sorghum, Toliposporium ehrenberger penicillaria, Toliposporium penicillaria. Now this Toliposporium is also assigned to the Sporisorium. Okay, why confusing spore? Like there are four rus are there, right? So grain, four smut, grain smut, head smut, long smut. It is also one more smut, that is a loose smut here, right? Yeah, loose smut supposed to be. It is here long smut. So all are now it is associated with Sporisorium one. And urocystis generally causes onion smut. Onion smut is caused by urocystis sepale, very important one. Flag smut of wheat, urocystis agropyri. Actually, this flag smut of wheat is introduced into India from Australia in 1906. In 1906, this disease was actually introduced to India from Australia. Okay. Tilicia and other things are like kernel bunt of wheat, Tilicia indica, common smut of wheat, Tilicia caris, black smut of rice, Tilicia barclayana, dwarf bunt of wheat, Tilicia controversa, stinking smut, Tilicia fetida, wheat bunt, Tilicia laevis, ryegrass bunt, Tilicia walkeri. Okay, so these are all some disease that is caused by the genera Tilicia. Another kind of things are there. You can read yourself. I will send you this, slides. Yeah, there are four different smuts are there, right? Grain smut, head smut, loose smut, long smut. So important points I will tell you, because already it's 7:15. I will finish it in just 2 minutes. Okay. So remember about the pathogen names. Grain smut, what is the pathogen? Head smut, what is the pathogen? Loose smut, what is the pathogen? Long smut, what is the pathogen? Okay. And the site of infection, very, 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 very important. So the grain smut mainly targets ovary. Loose smut also targets ovary. Long smut also targets ovary. But there is only one smut which targets inflorescence. It is a very, 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 very dangerous, because it is targeting inflorescence. Among the four smuts of sorghum, which smut is more dangerous? Head smut, because it is infecting inflorescence, entire inflorescence got destroyed. This is another important point. And another point is that disease survival. How it is surviving? Grain smut actually survive in the form of externally seed borne. Head smut survives seed borne and soil borne. Loose smut externally seed borne. But there is only one smut it spreads to airborne, that is a long smut. Long smut survives in airborne. Spreads through airborne. And you remember one more point. If you remember this order, like first grains will be there. That grains will be in the head. That head smut followed by loose smut followed by long smut. If you remember this order, there is one more point I will tell you. Spore viability. How many years it will survive? First grain smut 10 years, grain smut 10 years, head smut 2 years, loose smut 4 years, long smut 2 years. How to remember this? I will tell you. If you remember this order, grains grains will be in the head, followed by loose smut, followed by long smut. See, up to 1 to 10th we will study 10 years. So 10 years grain smut first come 10 years 1 to 10th class. Again +1 +2 2 years. Again BSc agriculture 4 years. Again MSc 2 years. Like that you will remember. 10 years plus 2 years means +2, plus 4 years BSc agriculture, plus 2 years masters in plant pathology, or maybe masters in botany, whatever it is, right? It is 2 years. Like that you just attach with the same order. Grain smut followed by head smut, followed by loose smut, followed by long smut. You match with the same 10 plus 2 plus 4 plus 2. Like that you match with it, then you will get it. The management is mostly recommended for Vitavax. For all smut disease, we do recommend carboxin or Vitavax, 2 gram per kilogram of seeds, right? Yeah. So modes of infection, I think last 2 slides only left. Okay. So modes of infection, there are 4 types of infection or modes of infection are there. Embryo infection or ovaricularis infection, which means they infect embryo at the time of blossoming. They will penetrate inside and they will infect through stigma. Not via stigma style, but directly through ovary. Okay. So embryo infection means they directly infects the embryo. So best example is wheat loose smut. So it is a very, 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 very important one. Embryonic infection example, wheat loose smut and loose smut of barley, both are the examples. And these two are also the examples of internally seed-borne pathogens. Wheat loose smut and barley loose smut, both are the examples of internally seed-borne pathogens. Very important. Second infection is floral infection. Generally, they infect floral pods. Valvatus spores can be observed. Best example is Compospot, Toliposporium penicillaria. The next one is seedling infection. Generally, they germinate with the seed coats and they causes infusion. I mean, like goes inside and causes the infection through this coleoptile. And example is the wheat flag smut, Urocystis triticale, and bunt of wheat, Tilicia caris. And another infection is a shoot infection, we can also call as culmiculus infection. Best example is a whip smut of sugarcane. Here another important point, take a look at this. Embryonic infection is also known as ovariculus infection. Another thing, shoot infection is also known as culmiculus infection. You please remember this one and along with the examples. Yeah, bunt, last one, bunts. They are actually classified under Tiliaceae, under order Tiliciales. The representative genera in the bunt causing disease are Tilicia, most important one is Tilicia, and also Neoaceae is also reported sometimes, Urocystis centraloma, but mostly Tilicia. 99% of the cases it is Tilicia. Tilicia causes bunt in disease generally in a gramineous crop. These are all the common bunt diseases, common bunt of wheat. Tilicia triticale or Tilicia caris, Tilicia laevis or Tilicia foetida, dwarf bunt of wheat, Tilicia controversa, kernel bunt, we can also call as partial bunt because only few partial grains are infected. That is Tilicia indica, we can also call as Neoaceae indica. Kernel smut of rice, which is caused by Tilicia barclayana, we can also call as Tilicia horrida. And other bunts are also there, but they're all very important one. Common bunt, also known as hill bunt, also known as Indian bunt, also known as European bunt, also known as stinking smut, also known as covered smut. These are all the other names of this common bunt. Okay, this common bunt have other names. Okay, the last slide, kernel bunt of wheat, we have already discussed. This is a very important one. The pathogen for kernel bunt is Tilicia indica. The synonym and other name is Neoaceae indica. Originally, this pathogen was first reported by Mintra in 1931 in a research station near Karnal. Karnal is one of the state in Haryana, right? So one of the place in Haryana. So in order to represent that area, he named it as a kernel bunt. It is not kernel bunt, it is a kernel bunt. Okay. So the air, it represents the area name. So when he discovered, Mitra discovered, he named the pathogen as a Tilicia indica. Later, the name changed to Neoaceae indica by B.B. Mungur in 1940 based on this teleal character. Again, there is a fight. This is actually belonging to Tilicia only, not Neoaceae. In the 1980s, there is an international conference. Again, it was assigned to both. You can use the both name, Tilicia indica, otherwise called as Neoaceae indica, both. Okay. So, as I told you, it is reported to Colonel Haryana 1931, hence it is named as Colonel Bunt. The phylum, it is belonging to Basidiomycota order Tiliciales. The infected the fields or the infected plant, they will produce a fishy odor, some kind of bad odor due to the presence of a chemical called trimethylamine. This is a very important trimethylamine. Let me ask you one more question. Infected pineapples also produces this fishy kind of odor. In pineapple, citrat of pineapple, there is a disease called citrat of pineapple. That citrat of pineapple infected plant also produces some kind of fishy odor. Here in kernel bunt, the fishy odor is due to trimethylamine. What about the citrat of pineapple fishy odor is due to? Are you guys are there?
Yes, sir.
The fishy odor of citrat of pineapple. Here in kernel bunt, it is due to trimethylamine. What about citrat of pineapple fishy odor is due to? Anyway, ethyl methyl acetate, it is important one. Remember, ethyl methyl acetate. Okay. So due to ethyl methyl acetate, the citrat of pineapple is also produces the fishy odor. But in the case of kernel bunt of wheat, is it due to trimethylamine? Okay. Infected parts, only grains. Majority of the times, 99% of that only grains. Okay. Most susceptible stages during flowering stage. That's why inflorescence get infected, right? So why it is called partial bunt? Because kernel bunt is also known as partial bunt, but majority of the cases only few grains per spike is infected. So for the management, we do recommend a method called hot water treatment, 52 degrees Celsius for 10 minutes for seeds. Kernel bunt survives in soil and as well as seed also. Okay. And kernel bunt mainly infect endosperm. In a couple of days before, we have one discussion with one of our member. So whether this kernel bunt infects only endosperm or embryo also. So most cases, 99% of the cases, it only infect endosperm. It never extend to embryo. In very severe cases, it may extend to embryo, but it causes no infection, or very rare cases it causes infection to embryo. But you remember, it causes infection only endosperm, but most of the cases no embryo infection is involved. That's why I mentioned this point. Mycelium of kernel bud pathogen penetrates the embryonic tissue, but it does not inflict the damage, which means it never causes damages to embryo. Only it causes infection to endosperm, not embryo. Okay. Yeah, this is the end.